Today's talk is about the special environment, the second phase. So, this is a categorization of the robot. So it is based on its application. Okay, and one is manufacturing. So I have talked the last time, the industrial robot. And this is next is a special environment. So it means the space or open field, disaster field, and battlefield. And also the support, social support, public service or personal service, both is for the social support. And then the final part is a little bit different because the humanoid is a human-like configuration robot. So it is used for every part. Okay? So I have categorized into this type. And today's talk is about this battlefield. The former space field and the disaster is talked next time. Okay? I have prepared much manuscript, but the time is limited, so I will show firstly about some overview of today's talk. Yes, yes. First, this part. Well, this part is military robot. Military robot. What is military robot? No, not necessarily, but the military robot is mainly the aerial vehicle robot and ground vehicle robot. Okay? Aerial vehicle robot, ground vehicle robot. And some general introduction you can find in some videos. Oh, sorry. PDF file, I have to say, PDF file has no linkage to this video, but if you want to find this kind of video, you should copy this part. Yes, 例えば for example, Lockheed Martin missiles and fire control. If you want to find this, you should this was into the Google, and you can find the movies, and then this Lockheed Martin missile and fire control, this YouTube video you can find. Okay, it is an easy way to find. Yes, these headings, this title should be input in the Google, and then you can find this. Okay, this is the easiest way to find the Just It movie or a similar movie you can find easy. Okay, this. なので、therefore, so if you want to watch the video, you can search in this way. You can find it in this way. Yes, this is the military robot part, and this is also the military vehicle robot, military vehicle. And other part is firstly, yes, this part is about the military mission. General information is there, and robotics field about military robot. It's the two major companies. One is iRobot. The other is Boston Dynamics. Some student knows already. The Boston iRobot is famous on this. Yes, iRobot part is these two seats, and Boston Dynamics the part is these seats, these 10 seats. Okay, and iRobot is famous about Giono. What is the famous iRobot product? in daily life? iRobot is producing this kind of weapon robot, military robot, but on the other hand, they are producing the commercially available consumer product. What it is? Yes? Yes, the vacuum cleaner robot. It is called Roomba. Okay, you know, Roomba robot, vacuum cleaning robot they are producing. And on the other hand, they are the famous company as a military robot, like this, okay? And Boston Dynamics is the, yes, iRobot is, I moved to this. iRobot is, this company is established by the MIT Rodney Brooks, Professor Rodney Brooks' team group is founded this company. Okay. Yes. And then this Boston Dynamics is founded by the Mark Raybert, Professor Mark Raybert's group established this company. Boston Dynamics っていうのは CMU、MIT でプロフェッサーのマーク・レイバートズグループ established this company. で、まあ、yes, both companies is supported by US military agency. Like this. Yes, this part. The Boston Dynamics has Rodney Brooks. You know Brooks ね。ブルックスでこのボストンダイナミクスっていうのはレイバートっていう人なんだけど、レイバート。両方とまあプロフェッサーだったんだけど、プロフェッサー。Yes. ですよね。Brooks is famous on his idea about the control schemes of moving robot. で、なんか、まあ、insect base, related to the insect's movement operations, the Brooks introduced some control schemes. I don't remember exact name his idea, but some distributed control. For example, some insect, なんか cockroach, like the six legs, and yes, and each leg has the なんか reflection, instant reflection each. Instant reflection movement that makes the totally the good control scheme for this body, total body. This kind of distributed autonomy he has introduced. Maybe you can search later. And the Mark Raybert is firstly famous on his jumping robot. He is firstly searching on this hopping type robot. Firstly, one leg hopping robot, and then the secondary two leg hopping robot, and then makes this kind of cheetah robot or some cat robot, dog robot. Company developed. Okay. So these two is firstly, they are the researcher on the university, professor at the university, but then established a company. And both is supported by military defense. And then presently it's very good robot they have produced. The other part is these four seed is killer robot present condition. Killer robot means the autonomously battlefield robot, and their stop killer robot campaign is started about 3 years ago, and this video shows this kind of activities, and some manuscript is published. So this part, okay. Yes. So let's look a little about each part. Yes. Military robot. Firstly, it's like what is this? This is the separated wheels, and this what is called this type. Eh? タンクだよね。タンク、ハーザー、クローラーね。for Japanese it is called caterpillar, crawler. Crawler is used for why crawler is used?
Easy movement in special condition of environment.
Uneven ground, not organized ground. They have to move. So therefore, this kind of crawler is usually used for these vehicles, and also for this kind of vehicles, wheeled vehicle. These has separate suspensions. Okay, supported separately using some suspension. Okay, and aerial vehicle. だからこれはグランドビークル、エアリアルビークルは AB だし、グランドビークル GB ですね。Yes. まあいいか。And the next slide shows one example. India is a French institute, Institut National de Research and Informatique and Automatique, is a French institute. The Robosoft is a French institute, the company. This Roborock is a famous vehicle using some robotic technology to ground vehicle. Yes. And then the next part shows iRobot's one product. Yes. Yes, this is the PackBot. PackBot is produced 2006, about 10 years ago. And PackBot is famous for the Japanese people because it is firstly inserted to inspect the Fukushima reactor building. Yes, not the Japanese robot. This PackBot US robot is inserted to search inside of the Fukushima reactor building. Firstly. So I will show this.
Tokyo Electric Power has supplied the first look inside two of the reactor buildings at the Fukushima Daiichi nuclear power plant. The video was shot on Sunday and Monday and shows the insides of units 2 and 3.
For April 17th is about a month later of this disaster.
The primary video came from a pair of robots sent inside, and the video supplied to the media comes from a camera trained at a couple of laptops being used to control the robots. Unit 3 experienced a hydrogen explosion on March 14th, and the video shows debris strewn around the inside of the first floor. In this shot, what appears to be a ladder is mangled against electrical equipment. The robot makes a steady pace forward across debris, a task that's all the easier thanks to its caterpillar tracks. Bit by bit, it moves ahead.
This robot is inserted, but it is partially developed for this bomb disposal, explosion ordnance disposal, or IDES, explosive devices, and big boom and something, and surveillance and checkpoint, route clearance, and explosion hazards identification, and hazardous material detection. So this video, yes. ちょっと待って、これね、良くないや。It's not good. Yes. これか。これは。
Tokyo Electric Power.
これか。
The story of 510 Packbot is about one life-saving idea, increasing the standoff distance between you and a dangerous situation. Your job calls you into situations many would run from. A nuclear plant after a natural disaster, where radiation levels are high, a building deemed unstable during a wave of terrorism. Into a barricaded situation, to assist with internal security, or to assess and render safe an explosive device, or a CBRNE threat. 510 Packbot allows police, military, and industrial personnel to do their jobs at safer standoff distances than ever before.
です。こういうようなロボットですね。And not only the military, but also civil defense, both worldwide, it has been used. More than 3,000 Packbot has been delivered, purchased by in the world. Yes, this is a more smaller type. Smaller type. Maybe you are interested in this. I don't first look over. This is good, maybe.
Get immediate situational awareness with the iRobot 110 First. A small, light, throwable robot.
Slower.
Weighing about 5 pounds, First Look is ideal for building clearing, raids, and other close-in scenarios. Or to remotely assess industrial environments. First Look allows operations where other robots can't fit or move. When communication is spotty, we establish it quickly using First Look's mesh radio capabilities. Multiple First Look robots can be set up to relay reliable communications and increase your operational range in challenging environments. First Look gives you eyes and ears with its 4 built-in cameras and its 2-way audio communication. Female subject, gun in her right hand. Put the gun down, put the gun down. First Look has a range of available accessories. Use First Look's optional integrated deployment and accessory camera to expand your visibility. Mounted on a flexible mast, the camera provides an adjustable 270-degree view with visible light illumination. Motorized retention pins make it fast to deliver a variety of small objects. To safely increase your situational awareness, use one of First Look's accessories in low-light situations, equipment with a thermal camera. Add the manipulator arm to lift objects remotely. Or use the hazmat sensors to remotely investigate an unknown situation. Use First Look to identify threats or get help with maritime interdiction at a safer standoff distance. First Look is lightweight, waterproof, and rugged. Use it in all weather conditions. It's maneuverable so you can use it to climb steps, roll over obstacles, or turn in place to overcome challenging conditions. Using First Look's rugged operator control unit is easy. Powered by iRobot Aware 2 robot intelligence software. The OCU includes an integrated radio, battery, and joystick.
はい、こういうやつですね。はい、この small robot is also developed about 5 years. And then the next is Boston Dynamics. Boston Dynamics is also supported by the US Defense Agency. And then also this kind of fault tolerant and this special field like tree climbing, wall climbing robot has been developed like this. And also this is rough terrain, this kind of place, and the swimming on the river, or it is also rough tolerant, can be operated. So I will show this. こっちでいいか。Swimming deck is there. Inverted operation. Up and down, no up and down. For okay, like this in any part it can move. And then also the Mark Raybert, as I said, has started with a jumping robot, hopping robot. So this kind of legged robot they have developed. Firstly, some fundamental research work on legged robot locomotion learning. This kind of fault terrain, rough terrain can be moved. So this is firstly searched on the UC California. I don't remember that much.
This video is a short overview of the quadruped locomotion control framework developed at USC as part of the DARPA Learning Locomotion project. This project aims to push the performance of robotic-legged locomotion to a new level. The locomotion controller, developed at the Computational Learning and Motor Control Lab at USC, is able to autonomously navigate across very challenging terrain, including obstacles and gaps as large as the full leg length of the robot. Special attention has been given to stability, smoothness, and movement speed, body movements that have been optimized for stable and dynamic movements even in highly challenging terrain.
In this case, this ground conditions is observed overhead camera, but it is calculating which part this leg should be put on. The place to put on is calculated by some computer, and then it moves. And for how to control each leg is mainly decided by the stability of this robot. Stability and the smoothness moving is considered. And then it said that also the speed of movement is also considered. Which part it should put on its leg.
Combined with leg movements that avoid the terrain in an optimal fashion. This gives unprecedented movement speed over very difficult terrain without sacrificing stability.
And also they are using the learning algorithm. Yes, foothold learning algorithm is also used. Yes, but
To be able to choose good footholds in rocky terrain, we developed a novel template-based foothold scoring system. Here, the robot learns optimal foothold choices from expert demonstration in a way that generalizes to previously unseen terrain. The controller is able to employ special moves for terrain that approaches the limits of kinematic feasibility of the robot. In case of slippage or other failures, special recovery behaviors are executed which save the robot and allow successful completion of the mission.
yes, recovery behavior is also learned on this.
Furthermore, we developed and implemented a novel floating-based inverse dynamics controller, which allows compliant locomotion over partially unknown terrain. Such performance is impossible with traditional high-gain position controllers that assume near perfect terrain knowledge. An additional benefit of such a controller is that it allows for safe human interaction with possibly dangerous robots. By combining these approaches, our controller sets a new standard for safe, fast, and robust autonomous locomotion over very rough terrain.
Very rough terrain とか言って、this kind of basic research is applied to this, the big dog とか other recent robots. Yes, I will skip this video. And also the cheetah robot is used to make, I will show this video first. Introducing this rider cat. This is more better. About 15 km per hour. Yes, this is 2012's record. And then watch this cat. And then also they have some more function about the obstacle jump. Okay, recently. 1 year ago, this is a video about obstacle jumping. Yes, MIT cheetah robot. Researchers have created new algorithm to autonomously jumping. Three real-time algorithms were implemented. Laser range scanner, the distance and the height will be detected, and then changes the jumping path. Yes, experimental result is there. they have, of course, they are planning the routine path about the running, and then the fan finds some obstacle. They are modifying its trajectory a little bit and changes the four-leg trajectory, after leg trajectory, rear leg trajectory, and then the jumped it. Okay. So next is so therefore these algorithms is applied to this robot, and NBC News. So and also not only for leg, but also the two-leg human-like robot, Petman, is also developed. Firstly, it is only the two legs model, but also upper body is added. How things move. Petman test. ちょっとこれ見ますか、最後最新です。Yes, DARPA is supporting this project. DARPA is Defense Advanced Research Project Promotion. Is, and also the Atlas. That's all. DARPA is supporting this kind of movement and manipulation. Autonomous movement and autonomous manipulation. So the one famous project is DARPA's Grand Challenge. Autonomous Vehicles Challenge is also famous. Autonomous Vehicle Project. Vehicle Project. It is started more than 10 years ago, and firstly the desert land autonomous vehicle moves. Firstly, the 10 kilometer and secondly 100 kilometer, and also not only this kind of open space, but also the urban cities autonomous vehicle project is also there. And then the next famous project for the robotics researchers is DARPA's Robot Challenge. DARPA's Robotics Challenge is also held the last 2 or 3 years, and it is for the disasters rescue robot or some disaster field, the maintaining robot, such as Fukushima's nuclear power plant. So this project is using the humanoid robot, and the project's task is driving the vehicle. One task is driving vehicle, other is opening a door and run inside the building, and then some works is there, such as the handling some object and connecting a wire or rotating the bulb or something, and then the move the rough terrain area, and then the climb the steps is and go to the goal is this robot project, robot competition project. Yes, there are two main project is very famous, and this Atlas robot is developed for the used for this latter project. So the operating robot still no disasters. Yes, I will show this video.
DARPA updated its humanoid rescue robot Atlas, but the changes show how far the machine still has to go to be useful in disaster zones. Atlas will be used by up to 7 teams in the DARPA Robotics Challenge later this year. The competition is aimed at developing robots that can help humans respond to natural and man-made disasters. Among the upgrades is a variable pressure pump that will help the robot conserve energy and also make it a lot quieter. Unlike previous versions, this robot is one that can run completely on batteries, albeit not for very long. Its 3.7 kilowatt-hour lithium-ion battery will give it about 1 hour of mixed mission operation. The new bot has 3 computers for processing sensor input for task planning as well as wireless communication abilities. During the challenge, it will face communication blackouts of up to 1 minute, and it will need to operate autonomously. $3.5 million will be awarded to the top 3 finishers in the challenge. In Boston, Nick Barber, IDG News Service.
というさで、その DARPA Robotics Challenge has been done the last year. I will introduce later in this course. Okay? And this robot is also applied to other works, not only this DARPA Robotics Challenge. Yes, DARPA Robotics Challenge is pictured here. And this is another task, the cleaning the house is also applied. I will show this video. Treating daily objects, daily tools for human beings. For 20 times faster than real time. Okay? Brush. Bottle put into the plastic. And on the ground it can reach. これ完璧に投げたんですか。最後はこれも it's also recent robot and it's very famous for the US people because this robot can get up by itself. Yes, I will show this about 2 minutes video of this. uneven, rough terrain, and slippery condition. Pound box, about 5 kilograms, 4 kilograms. Using the mark, Okay, yes. For a recent year. Yes. And the next part, is yes, killer robot. So you can see many killer robot videos there. Killer autonomous robot finds the target and attack by bombing or something. This kind of autonomous killer robot has been developed. For example, yes, recently some drones is very become popular, but it is also some dangerous aspect. Self-guided boat vehicles are coming is also some video and a new military robot technology document. And so also, therefore, some campaign to stop killer robot is there. It is started the 2013 April to prevent fully autonomous weapons. It says Human Rights Watch. This is NGO is saying that it should become the global campaign to stop the killer robot, because this future weapon has some dangerous side, because it can only detect and think by itself, and it cannot find that is truly. It is surely true or not. Yes, this is also some report is saying that the UN urged to ban the killer robot before they can be developed. So this is also another report is also here. So I will show the campaign's contents like this. Some introduction animation is here. これか、例えば。For example, this.
When I say killer robot, probably the first thing that springs to mind is some fight scene out of a science fiction action movie. You might think, awesome idea, or nah, not really my thing. But did you know that precursors to killer robots are actually being developed right now? Killer robots are robotic weapons that choose and fire at targets, all of their own accord, without any human intervention. Sounds crazy, right? Well, their predecessors are already active. Take the US X-47B, the first unmanned aerial vehicle to take off and land at sea. The X-47B demonstrates how technology is advancing from remote-controlled to autonomous aircraft. Or the semi-autonomous robots on the South Korean border that lock onto anything suspicious coming from North Korea. Robots are slowly taking over the role of humans in war zones. Unless action is taken to stop this, soon it won't be humans that decide over matters such as life and death, but machines. It's questionable whether these machines will take something like international humanitarian law into account. Would a machine be able to distinguish between a military target and a civilian? And who would be held accountable when things go wrong? The manufacturer, programmer, or the robot? Moreover, does it make it all too easy for governments to use violence? During the Obama administration, the use of armed drones has increased, and so has the number of civilian casualties caused by armed drones. 10 years ago, we wouldn't have been able to imagine drones taking center stage in the way we fight wars today. Let's take control of our future by insisting that humans, not machines, are always responsible for the use of force. We are calling on all nations to consider ethical, legal, and military concerns over fully autonomous weapons, and to work towards a ban on the development, production, and the use of these weapons. Share this video and go to our website for more information on killer robots and what you can do to stop this.
Fully autonomous robot is dangerous, they think, of course. And also, as a video, I will show the similar video in the last year's video like this. They say the cleaning robot and the surgical robot is very useful, so they're not anti-robots. But US military has been developing weapons drones for years. Yes. アルカイダとかパキスタンとかアフガニスタンとか、it's also what's the next? Predator, military drone, fully autonomous means.
Utter the words killer robot and it's almost impossible not to picture the Terminator, the time-travelling autonomous murder machine that absolutely will not stop until its target is destroyed. The T-800 is the work of science fiction, but the campaign to stop killer robots, a coalition of more than 50 non-governmental organisations, believes nations must act now to ensure a machine is never given the choice to take a human life.
The campaign is trying to get an international prohibition, legally binding, to stop autonomous weapon systems, production, development and use of these. An autonomous weapon system is a system, a weapon that once it's been activated or launched, decides to select its own targets, and tracks and selects targets and kills them without further human intervention. So our aim is to prevent the kill decision being given to a machine. In other words, we don't want machines to be delegated with the decision to kill.
Launched 2 years ago, the campaign to stop killer robots says we're all too close to giving already advanced robotic weaponry the responsibility of killing. Campaign coordinator, the Human Rights Watch, has previously pointed to hardware such as US anti-missile tech, South Korean sentry robots,
or the UK's prototype unmanned Tyrannus aircraft as examples of the kind of systems that could be made fully autonomous, letting a computer pull the trigger, a scenario that the campaign says would be pragmatically and morally problematic.
Can they weigh up the advantage against the potential harm to civilians? Is that possible? Who would be responsible for a strike when essentially it's the machine that's been pre-programmed to pull the trigger? Do we want to live in a world where we have given machines the power to take human lives without a human being even being there to pull the trigger when the target is being attacked?
As technology advances, AI is poised to become a bigger part of our lives, from everyday gadgets like robot vacuum cleaners to emerging tech like Google's self-driving cars. Robotics professor Noel Sharkey is keen to point out, however, that the campaign's gripe is with autonomous machines that kill, not with AI in general.
If they developed autonomous bomb disposal robots, that would be a great technology, but there aren't the billions of dollars going into that there will be into autonomous weapons. So the only thing we want to stop is the kill decision being made by a machine. All the other technological developments before that point are fine with us.
The campaign hopes that the world's nations can agree to ban killer robots, akin to international agreements on other types of warfare, for instance chemical weapons. That kind of global agreement is a huge task, but those involved say they are making progress.
So since the campaign's launch in 2013, the United Nations body tasked with banning weapons has taken it up. It's on the agenda. They've had 2 international discussions on the topic, and they will decide at the end of this year whether to continue discussions or to move into a negotiating mode towards an international treaty. That's what we're pushing for, and we think it's inevitable.
It's almost 100 years since the term robot was first introduced, and humankind's fascination with the idea of a deadly automaton has never waned. From theatre to the silver screen, we get a giddy thrill at the notion of our own mechanical creations getting out of hand, turning against their human masters. It's all rather poetic when you see it on screen, but the killing machines of real life are more mundane and a lot more frightening.
The real ones are worse in many ways. They will look like tanks. They will look like ships, battleships. They will look like jet fighters. They might look a bit like something futuristic, like something Batman would fly, but that's what they'll look like.
It's not so long ago that people didn't know what drones were. The idea of drones flying around firing missiles was totally crazy, but now it's suddenly completely a sort of almost inevitable part of conflict. And so I think we need to be aware that actually what we're looking at are systems that are on the brink of emerging, and we need to draw the line now, otherwise we're going to be sleepwalking into a system where we have fully autonomous weapons and we can't turn back.
Do you agree with the campaign's goals, or do you have some reservations? Let us know and stay tuned to CNET.
It means, yes. They say that once this kind of autonomous weapon is launched in the field, yes, they think by itself. They, this kind of killer robot think by itself, but maybe he cannot distinguish who is a soldier, who is a civilian people. Maybe. Yes, kill person, kill human, but they cannot distinguish well who is a soldier, who is an army, who is a normal people, general people. So, for example, Mind Gap is one manuscript. The report details about this kind of things. So if you are interested, you should access this and download this PDF file. Okay. Yes. So therefore, before closing this topic, I will show this subject. So today's subject is killer robot and campaign to stop the killer robot. Okay. One is write about what is the condition of killer robot. You should explore on the net or some bibliographic survey or something. You should do it, and it should be write up, summarize what you have searched. And then the second part is about the campaign to stop the killer robot. What it is, what is the goal of this campaign? Okay. The first part is about the killer robot present condition. Second part is a campaign to stop the killer robot. Okay. And then thirdly, discuss about your consideration, evaluation, discussion about these two things. Okay. And then the fourthly is a reference list of your work. It's this. So therefore, you may have 1 week holidays next week. So you should do it carefully. For example, watching these videos, watching these campaigns video, or this killer robot present condition, or something. It's okay. I have introduced something about this, but also you can do anyway, any material, any video you can find on the net maybe. And then one answer, response to today's exercise, I will show this video finally. The DARPA is a Defense Advanced Research Project agency, and they are promoting, as I said, the Autonomous People project and also the Robotics Challenge. Two important projects they have promoted. Why it is? This is one person of the important person of the DARPA's project. So she replied something about this.
I made a little list here of some of the projects that DARPA has played a key role in over the last few decades. You've got the internet, GPS starting in 1959, virtual reality, satellites, stealth aircraft, UAVs, unmanned aerial vehicles, night vision, precision guidance, smartphones, even Siri. I mean, the list goes on and on.
It's a tremendous heritage. And of course, the challenge for those of us who have the privilege of serving at DARPA today, our job is to make the investments now in 2014 that become those kinds of transformations for the next generation.
Give me an example of a surprise that DARPA created.
One example is stealth aircraft that allowed our warfighters to go into very contested environments and evade radar, which was an amazing new capability when that became possible.
The stealth fighter, the B-2 bomber.
Exactly. And then on the enabling technology side, 45 years ago, DARPA did this sort of crazy experiment, which was to hook a couple of computers together and have them talk to each other. That was the beginning of the ARPANET, which became the internet today.
So Al Gore, eat your heart out, DARPA invented the internet.
Al Gore did a lot to make it the real internet that we've got today, but DARPA planted the very first seeds for that.
Yeah. So can DARPA say we created the internet, or they can say we did something very early that got it going?
We created the ARPANET, which was the predecessor network, and the internet grew out of that. And like so many of our investments, we plant these early seeds that create a technology base, and then after that, vast numbers of other people across the technology community and a huge amount of entrepreneurship and private capital, all of that has to happen to turn those ideas in the technology base into the internet and the smartphone that you have in your pocket and the technologies that have changed how we live and work.
So the smartphone too. DARPA had a role in what we now know as the smartphone.
A lot of the technologies that went into the smartphone. So the chip that's in your phone that talks to the cell tower and sends a radio signal actually shares a common heritage with the really sophisticated radars that are on Navy ships that help us see where the adversary is. They both trace back to core technology investments to make semiconductor components be able to send radio waves.
So when Siri just isn't listening to me, can I say duck on DARPA?
You should try it, see what happens. That would be great.
See if she responds, see if she gets it together.
Yes, so ちょっともう一個見ますか? Yes.
We're always looking to see where the frontiers of science are generating amazing new innovation, because that's where the seeds of technological surprise are going to be. And in biology today, we're getting those signals about what's going to be possible from neuroscience as we develop new ways to understand the brain and to repair damage to the brain, but also in the future enhance what we're able to do with our brains. amazing things are going to come out of that kind of work.
Yeah. Can you even imagine what could come out?
Well, we're starting to be able to imagine it. One of our programs a few years ago, one of our programs was revolutionizing prosthetics, and it set out to give our wounded warriors who had lost limbs in these terrible violent incidents overseas, we wanted to give them a better option than a simple hook, which had been the standard of practice for decades. So the second part of what he did was start understanding neural signaling from our motor cortex. What are the signals that allow us to control our limbs? That work culminated in human trials in the last few years, and in particular, one of our wonderful volunteers is a woman named Jan. She's a quadriplegic, but she's had these implants now on her motor cortex, 2 tiny little chips that pick up her neural signals, and she uses her thoughts to control this sophisticated mechanical arm. Now, it's so exciting to think about what kind of restoration we could do with that for people who have lost their ability to control a limb or have lost a limb. But of course, it also opens this other door, because now we can go directly from the brain into the mechanical world. And that's, I think it's exciting and terrifying to think about what's on the other side. And we're going to have to we as a society are going to have to think hard about where we want to go.
What is terrifying about it?
Lets us imagine a future, possibly, where there are ways to be able to do that kind of pickup of neural signaling, fine detailed pickup of neural signaling, without having to use surgical techniques. And if we got to that future, you can imagine a pilot flying a plane, instead of having a neural signal that tells him how to control the controls through his limbs. Imagine if he was able to eliminate that latency and fly the plane directly
from his brain.
Right. That's the part that sounds exciting, but once you can do that.
But that also sounds a little scary.
Exactly. And I think that's the nature of these leading edge technologies, is we pursue them because of their promise, but we know that they're going to pose really interesting and important challenges for us as a society.
というわけで、yes, unfortunately, yes, that's true. That's true that war is promote the development of technology. Okay? Yeah, yes, because this is competition, beating others, and we have to survive. So the war promotes the technical development, of course. And also, war makes some injuries. For example, so they have said the processes technology, artificial limb technology is developed after the war. And also the remote surgical operation. Yes, Da Vinci is also developed firstly for this kind of remote operation. Remote surgical operation, so therefore the makes the promotion of the technology. But also the military technology is also used in real life, general public, such as the internet technology, vaccine, GPS technology, and freezing drying is a food keeping, and EpiPen is some drug injection system. Yes, cargo pants, yes, some kind of wear, and duct tape. Tape is good tape to maintain everything, and gas pans and jeep and computers, microwave oven. Microwave is firstly as a weapon, of course. And the refrigerator, digital camera, antibiotics, and counterfeit, and ambulance services. Yes, this kind of carry the patient to the hospital. This kind of service operation is developed in the warfield, battlefield. Yes, sunglass, night sea, safety lasers, and some kind of feminine engine product, and super glue is also developed. It is presently used for the used for the daily fabrics. So this some technology is two aspects. One is on the bad side and one is the good side. All of the technology has both sides, but how to control it is very, very important.